Okay, so let's start this problem by thinking about what cards we can draw that won't ruin our chances. So clearly, if we draw a six of clubs as our first card, our chances are ruined, right? We need all five cards to be 10, jack, queen, king, ace of some suit, and this is not any of that. So our first card needs to be a 10, a jack, a queen, a king, or an ace. So how many of those are there? There's five in each suit, and there's four suits. So there's 20 cards out of 52 that can be our first card that won't ruin our chances. Okay, so given that this has happened, what are our chances of not ruining our chances on the second draw? Well, we need let's say we drew a 10. We need a jack, a queen, a king, or an ace. And it doesn't matter which one of those you draw first, you just omit that. So if we had drawn a king first, it'd be 10, jack, queen, or ace. But we now specifically need to draw them from the suit of the first card we drew. If we drew a 10 of clubs first, we need jack, queen, king, or ace of clubs. And so the probability gets a lot lower here. We have only four cards, these four, all of clubs, or whatever suit we drew, out of 51. Keep in mind it's 51 because we already removed a card. So we're down to 51 cards now. Okay, next, let's say we drew a king. We need a jack, a queen, or an ace. Point is, there are three cards remaining we want to draw. We need any of these, and so there's probably 3 out of 50. Again, the number goes down because we've drawn another card. And then we can go very similarly. Let's say we drew the queen. We need a jack or an ace. So there's 2 out of 49 cards. And then let's say, we draw the ace, so now we just need a jack. And so now there's only 1 out of 48. Okay, so we have all these individual probabilities. What can we actually do with them? Well, we need to multiply them. And this might seem weird because you need independent events to do this, but not quite. These are actually conditional probabilities. So this one is conditional. It's the probability that we don't ruin our chances on the second draw, given that we didn't ruin them on the first draw. So remember that P of A and B is always equal to P of A times P of B given A. And so we're just multiplying down this chain, which we're allowed to do because they're conditional probabilities. And we end up getting a number that's really, really small. It's like 0.0000015%, roughly. And so it's a tiny, tiny chance of getting this royal flush, which is why it's so rare. Even in games where you draw more than 5 cards, it's still really, really rare.